This week on BSD Now, we're going to be leading off with the latest news about Wayland and Xorg support on FreeBSD, then a look at OpenBSD's ARM64 support, inside the Cha-Cha-20 cipher, and much more. All this on your place to be, SD. BSD Now, episode 179, The Wayland Machine, recorded January 25th, 2017. Hey, I'm your host, Chris Moore.
And I'm Alan Jude.
Glad to have you with us this week. So you'll notice the date's a little wonky. So yes, we're recording a little bit ahead of time. We've got things coming up and trips and whatnot. So we don't want to leave you hanging without a new episode. So we have never really done that, except for that one best of show for Christmas. Does that really count? Because Jupiter kind of did that to us.
Well, for us. It was nice to have the day off.
For us, but you know. Yeah, it was nice to have the day off, I admit. So I don't know if our track record really has been messed up at all. We're still good.
Yeah. 1 out of 175 didn't hurt anybody.
No, not at all. Not at all. So let's get right into the news here. So as the title hinted at, we have some Wayland news to talk about. And so tell us what landed in ports. And first of all, I was surprised to see this land so quick. I thought we were a ways off, but very cool.
So this commit here that we've linked from Baptiste brings in Wayland, the new windowing system, into the FreeBSD port tree. This port was first created by Coop Mast, or KWM, at FreeBSD.org, but then was updated and improved by Johannes Lundberg, who we've been seeing the tweets from lately about the work, but it's now ready for you to start playing with.
That's great.
Wayland is intended as a simpler replacement for X to allow for being easier to develop for and maintain, and it's expected that GNOME and KDE will switch over to it eventually. So that's why
I know. Well, Qt's already switched over, so KDE's the toolkit they use is essentially already ported over, so that'll make it easier.
So I think this was not quite a blocker, but definitely would make getting KDE 5 much easier.
This is really cool because we need to get Lumina ported over to it as well. I know Ken would love just to ditch all the X stuff he did and do Wayland directly.
Yeah. So Wayland's designed more for desktop and laptop type use, which is what almost everybody uses X for. Whereas X's original design was, you have big servers that would run the apps and then clients that would just display the screen of the app. That's not really what happens most now, and dragging all that excess complexity around is maybe not a great idea. Most of the time now, the clients are much more powerful than the servers back in the day were, and are perfectly happy to run applications locally. Wayland is a protocol for a compositor to talk to its clients, as well as a C library that implements that protocol. The compositor can be a standalone display server running on a Linux kernel mode setting driver with EVDev input devices, or it can be an X application or a Wayland client itself. The clients can be traditional applications, X servers, both rootless and full screen, and other display servers.
Interesting.
So this is available in ports. People can start playing with it. If you find problems, please report them in the FreeBSD bug tracker. It'll be interesting.
I wonder, I'll have to try
Lumina move over to this, maybe.
Yeah. Having Lumina move over to it'll be a big thing for us. Like we're gonna want to pursue that pretty aggressively for TrueOS, I'm sure. It'd be interesting to see though how it plays well with the DRM work that Matt Macy's been doing as well. If it works better than X with it.
Well, I know in particular that I've heard that Intel's driver team mostly only cares about Wayland for newer versions of their driver, and if that's the case, then us at least having a decent story of Wayland maybe will be a lifesaver for us. But
that might be the thing that makes my laptop work better instead of trying to wait for the Xorg userland drivers to get synced up with the DRM bits. As long as the DRM bits are good in the kernel, maybe Wayland's the way to go forward here.
Speaking of that,
I'm excited.
Did you see what the next story is?
No, I did not. I had not read ahead yet. Oh, what do you know? What a coincidence. Okay, well, tell us about the next story.
Yeah, so Baptiste and the FreeBSD X11 team have issued a call for testing for the upgrade to Xorg 1.18.4 and the new Intel and ATI Xorg drivers to match the new kernel drivers. So now that 10.1 and 10.2 are gone, we can start moving forward on this stuff. So there's a patch against the head of ports tree called new xorg.diff, and this will upgrade all the XF86 packages and drivers and allow you to use the new XDDX drivers that will then hook up to the kernel part. So installing this on FreeBSD 11 currently, don't expect any new GPU support because that relies on the kernel part. However, getting this tested is important in order for us to be able to actually use the new kernel driver when that does come in with the i905 stuff. So I'm guessing that combining this patch with, well, I guess if you're using the DRM next branch, you're supposed to already be using a newer branch of the ports tree that has this stuff as well.
Tree, yep.
But this will allow us to test and make sure that new X stuff can go into the regular ports tree, and will reduce the workload of having to maintain the two separate ports trees.
Screw it. I just want to switch to Wayland and be done with it. It's just,
it's a bit soon for that, I think, Chris.
I'm getting a little aggressive.
Yeah.
I apologize. It's just,
in particular, not a lot of apps work very well yet. I think, was it Weston or whatever, which is the window manager for Wayland or something, only does full screen apps or something?
So all we need to do is we're going to port over PCDM and Lumina.
Yeah.
And if we have those two things, then you can run all your other apps with the XCompat stuff. Like that's a thing. So yeah, that's cool. I'm excited.
Yeah, but it's just interesting that you're like, yeah, we got to wait for the X drivers. Like, well, here's your X drivers.
Here's your X drivers. I guess we're good to go.
Yeah. But yes, it'd be great for people to try that out on their various hardware and report back to the FreeBSD X11 team how that goes.
So for those on TrueOS waiting for these, I've already pulled a lot of this stuff already in. We got a new package set we're still building now. Probably a few more days, maybe early next week before we push it out.
Cool.
For people to try this out.
Nice.
Let's see. And then the note here, too, if you experience issues with Intel or Radeon driver, try to use the new mode setting driver provided by Xorg directly. And they note that Fedora and Debian recommend the use of this new driver instead of ATI and Intel. And I will note that's what we do on TrueOS as well. We've found the mode setting driver is a lot more reliable than the Intel driver.
Yep.
So,
and the lines to put in your modesetting.conf are right there in the link. It's just 4 extra lines to add to that file, and you're good to go.
Cool. Okay, well, time for our first sponsor this week, which we're going to be starting with DigitalOcean, website for that, digitalocean.com. You'll want to go there, create an account, which will take you just a couple minutes. And then after you've done that, don't forget the little magic coupon code you put in, FreeBSD Now, all one word, all lowercase. And of course, that's how they know you heard about it here. But then for you, you get a $10 credit, which is pretty fantastic because that $10 credit could let you run one of their lowest end VMs for 2 months, which for a low end VM, I mean, you're still on SSDs and you got lots of memory. So sure, you can do a lot of cool stuff with that. But you could even rent and maybe run one hourly and pay the fraction of that. So if you're only spinning up stuff on the weekend to kind of play around and then, going to shut it down at the end of the day when you're done with your tinkering, like you could do that and stretch that $10 credit out for quite a while. But I have a feeling you'll be hooked. There's a lot of neat things you can do in DigitalOcean, and we've covered them over the years for sure. But of course, their API is really phenomenal. So if you need to programmatically bring up VMs and tear them down and clone them and configure them, like do all that through their API. That's really slick. Another thing is they have service centers or data centers all over the world. So of course, you can pick something really close to you. So say you're running like a Mumble server and you want it, close to your house. For low latency, yep, you can totally do that. Or if you want to send something to the other side of the world, like maybe you're doing a redundant page for like a service status, like Alan does with his. Maybe you want that in a location not potentially affected by the same natural disaster as wherever your primary servers are located. So put it on the other side of the world. But definitely really cool, and check it out today. They offer FreeBSD natively and FreeBSD with ZFS as well. And you can throw open and net and drag and all that works as well. So definitely no reason not to give them a shot. And if you've been looking for a provider, definitely give DigitalOcean a try.
Yeah, like Chris mentioned, they have locations in San Francisco, Toronto, New York, London, Amsterdam, Frankfurt, Bangalore, and Singapore. So that's pretty good coverage across the globe. Yep.
Okay. So let's see here. So we got our next story to go to, error handling in C. Yes. Ted Ewangst has something for us.
To error, no, or to error.
That's right. So tell us what he's got going on here.
Yeah, it says, unlike other languages, which have one preferred means of signaling an error, C is a multi-error paradigm language. Error handling styles in C can be organized into one of several distinct styles, such as popular or correct. So he provides a whole bunch of examples. So one of the most popular ones is returning -1 as the return code in the case of an error. So you can see here, you try to open a file. If the file doesn't exist or you don't have permission or whatever, you get back the file descriptor -1 and you know you have an error. Then you have the standard C library, which likes to use null for errors. So if you try to fopen a file and your pointer to it is null, then you know that it didn't work.
Sure.
So the latter has the advantage that null is a false value, which makes it easier to write logical conditions, whereas file descriptor 0 is valid, but false, while -1 is invalid, but true. So you can see that can cause problems. And he says, and of course, it's there's the worst of both worlds, which requires a special sentinel, so where you have to actually check for a named value with nmap, where you have to actually look for map_failed. And if you forget to do that or do it wrong, then you might run into a problem. And this is other Unix functions that don't need to return a file descriptor stick with 0 or -1, like listen. So, if listen returns anything other than 0, we know there's a problem.
Sure.
It says, of course, none of these functions reveal anything about the nature of the error. For that, you have to consult the error no value. So, when we do fstat on a file and we get back -1, we then have to look at the error no and figure out, was it a permissions problem or some other problem? And then maybe treat that differently. And since other functions take approaches that don't have any error return at all, instead requiring various degrees of T-leaf inspection. So, when you do stir to long or stir toll on it, you have to check, was the first byte a 0 byte, or, does it point to a 0? Then yes, it was not a number. Or you can check the error no for, was it out of range, or was it the maximum or minimum possible value? Then throw an error. Then you get ones that actually return an error, like getAtterInfo. These later functions started using a dedicated error return that encoded what went wrong there in the error. So with these functions, the actual value you're trying to get out of the function, you basically give it a pointer to give it the pointer you want it to write the result to, and the return value of the function is actually whether that worked or not. So it returns the error, and you basically give it pointers to what it should do with the answer. So that style. And the somewhat more simple in the new POSIX functions is it just returns 0 or true or false, and so then you can just do a regular if. And he says that works pretty well, and it's generally hard to screw up. But when you have something that returns a value, like stir to num, which I think is an OpenBSD invention, this flips the error and return values in those functions. So stir to num always returns the value, and you give it a pointer to where you want it to store the error. And then you can check if that error is 0 or something else. So if there's error, then abort. He says this is necessary to make functions work with integers of all sizes without resorting to a circus of stir to short, stir to int, stir to long, stir to uint32, etc. More than 20 years after the introduction of LP64 architectures, it's still possible to find code that does the wrong thing, like casting a long into an int. Then you have libraries that are more complicated and have a context, like the libTLS that came out of LibreSSL. You do TLS connect on a context to a host and a port, and then you have to it returns success or failure, and then you have to run the TLS error function on that context to extract the error.
Sure.
Or they have another example here, SQLite. You run the SQLite 3 step on a certain statement, and if it returns not a row, then you have to call SQLite 3 error message on that database connection.
I just gotta say, man, using Go, I did a little bit of Go programming, and boy, they have it a lot easier over there, where you can return multiple values.
Yes,
so you can always return the error and then the explanation, right?
That's definitely the thing I missed coming from. I spent a lot of time programming PHP, and then I came over to C. I'm like, how am I supposed to indicate that this didn't work, but also still return something.
Right.
I was like, But now I have a list of all the different bad ways I could do it. And then it actually talks about how in xlib you actually have callbacks. So you have to make your own error handling function. And then in PNG and JPEG, you have to have your own error handling function, but those can never return.
Okay.
So when error handler is something that had better call long jump, it's going to be a long day. And then you see, there's plenty more, often some combination of the above put together. It's,
Yeah. All the bad ways you could do this.
I looked enviously at NetBSD's got a little .h file that defines a bunch of like malloc x, which basically does the malloc. If it fails, it exits. And so you don't have to add that if check after every malloc in your code. And so on. I'm like, I'm starting to like this idea.
Right.
Yeah.
Oh, man. All right. Well, very cool. I appreciate you giving us that info. Did he have one he recommended over all the others?
Not really. I think he liked the doing the return value and putting the error in to the pointer, like stir to num. Although it sounds like he liked the new POSIX one, like POSIX memo line. Although that one doesn't ever return an error message, so that's not as helpful.
Sure. Okay, well, speaking of POSIX, so somebody else got a bone to pick here. Yep. Fixing POSIX file names. So what's going on here? It looks like dwheeler.com has an article about that.
Yes.
So tell us what's wrong with POSIX file names. What are they fixing here?
Well, they're arguing that we should fix it, not actually necessarily fixing it.
Okay, so there's no code yet, but we're making the case. Right. Okay.
But it's basically the case is that control characters such as new line, leading dashes, and other problems in file names make file names ridiculously hard to work with. Which is true. And we have some great shell script and so on examples to show that. But traditionally, Unix, whether that's Linux or POSIX or whatever, path names and file names could be almost any sequence of bytes. A path name lets you select a particular file and may include 0 or more / characters that separate the path name components into the directories and so on. And then each part is a file name. File names cannot contain a slash. And file names cannot contain a null byte, the /0 character. But other than that, pretty much anything goes, which is great, except for it's not.
Right. It's wonderful until it doesn't.
Yeah. This lack of limitations is flexible, but it also creates a legion of unnecessary problems. In particular, this lack of limitation makes it unnecessarily difficult to write complete programs and enables many security flaws. It also makes it impossible to consistently and accurately display file names, causing portability problems and confusing users. Yeah, I think we should have just never allowed spaces in file names ever. That would have been my vote.
That would have been helpful.
That was a bad idea. This article will try to convince you that adding some tiny limitations to the legal Unix POSIX file names would be an improvement. Many programs already presume these limitations and therefore run into problems. The POSIX standards already permits such limitations, and many Unix and Linux file systems already embed such limitations. But it'd be better to make these reasonable assumptions true in the first place instead of, being caught out when it isn't necessarily the case. This article will discuss, in particular, the 3 biggest problems: control characters in file names, like new lines, tabs, and escapes, leading dashes in file names, and the lack of a standard character encoding scheme instead of using UTF-8.
Sure.
These 3 problems impact programs written in any language on Unix or Linux or POSIX. There are other problems, of course. Spaces in file names can cause problems. It's probably hopeless to ban them outright, but resolving some of these issues will simplify handling spaces in file names. For example, when using a Bourne shell, you can use the IFS trick and set your IFS to new lines or tabs and not spaces, and then all of a sudden it's safe to deal with spaces. Similarly, special meta characters in file names cause some problems. I suspect a few, if any, meta characters could be forbidden in all POSIX systems, but it'd be great if administrators could locally configure systems so they could prevent or escape such file names when they want to. I then discuss some of the tricks that can help deal with this. It says, after limiting file names slightly, creating completely correct programs is much easier, and some vulnerabilities in existing programs disappear. This article then notes some of the other options. I knew that some people wouldn't agree with me, but I'm heartened that so many do agree that something should be done. Finally, I briefly discuss some methods of solving this long term, these including forbidden creation of such file names going forward, and hiding the existing ones on the underlying file system so that you have to specifically go after them. Implementing escaping mechanisms, like actually teaching the shell to deal with some of this for you, or changing how tools work so these are no longer a problem. I.e., when you're using the globbing or scanning code, have it prefix all file names with // for any files that might be a problem.
With a
if
dash,
it starts with a dash or something that might be misinterpreted, have the shell globbing system automatically just put // in front of it to make it not start with a dash. He says, solving this is not easy, and I suspect that several solutions will be needed. In fact, this paper became long over time because I kept finding new problems that needed explaining, or new worms under the rocks. If I've convinced you that this needs to be improved, I'd like your help in figuring out how best to do that. Yeah, so file name problems affect programs written in any programming language. However, they can be especially tricky to deal with in the Bourne shell, even if that happens to be bash or dash, not just sh. If you just want to write shell programs that can handle file names correctly, you should see the short companion article, File Names and Pass in Shell, How to Do It Correctly. This, I know, has caught lots of people, where you write a loop and it looks like it works great, but then a file with a space in the name all of a sudden does the wrong thing. Or a file with a space and a dash or something, and you get all kinds of weird things happening. There's some tricks to deal with, but you usually forget to do them.
Because they require more work, right? It's just easier to do the initial, that worked for me, and then find out it breaks on somebody else's.
Basically, if you're scripting using RM with a shell variable something, you should always put the dash before the variable. So if the variable contains any dashes, they're interpreted as literal dashes, not as flags for the RM command. Otherwise, if someone were to create a file called -rm space /, you can't have the slash, but something like that, then all of a sudden, the RM will not interpret that as delete this little text file. It would interpret it as recursively remove everything named everything after the space. And all of a sudden, it's deleting a file you didn't want it to. And you're like, well, what happened here? It's like, your shell script didn't properly escape that special character, and now everything exploded in your face.
Yeah.
So he says, imagine you don't know your Unix, Linux, POSIX as well as you think you do, and you're trying to do some simple tasks. For our purposes, we will create simple scripts at the command line using the Bourne shell for these tasks. So if you actually look here, he's just trying to concatenate all the text files in a directory into a new file.
Sure.
Right? So cat star redirect to / collection, you would think that'd be fine, right? No, wrong. This list doesn't include any hidden files that start with a dot. Maybe that's what you wanted, maybe it's not. But also, if the file happens to start with a dash in it, then you're in trouble. File starts with had a space in it, maybe that's not going to work, and so on, and so on, and so on. Yeah, so if a file had -n in it and you're using GNUCat, all of a sudden every one of your lines has numbers in it, and that's not what you wanted. And so you better invoke it with -- before the star to make it not interpret those, and so on.
Sure.
So apparently the correct thing to do is cat /* and when the shell glob expands that, it'll have / in front of each file name, and that will neuter any of the dashes. But it still doesn't help you in the case of spaces. And then there's an example using find to do it. It's like there's obvious problems with this one because you're constructing the whole list and then doing it, but that doesn't work either. So then they try doing a for loop. It's like, actually, that one's going to break on spaces as well. And then they try some other stuff. It's like, nope, not going to work. Even the find one that they do where they pipe find into Xargs and cat in a subshell and then redirect it. It's like, nope, that's also not going to work. You need to use the print 0 option out of find and Xargs -0 to actually get that list of files separated by null bytes instead of new lines, so that the spaces are interpreted as part of the file and not as a separator between the files. And on and on.
So I gotta say, you're making his case pretty well here, Alan, because just going through all the examples of this, I'm already like, wow, this is way too complicated. I don't want to have to think of all those.
There's a bunch of them, and it's like, you know what? All of this, I've seen people run into these problems. But yes, the correct one, but technically isn't part of the POSIX standard, is print 0 pipe Xarg -0.
Sure.
And there's a couple other options, but it's like, wow, that's, And he's like, oh, and don't try to display any file names. File names can contain control characters that control the terminal or X windows, causing nasty side effects on display. Displaying a file name can even cause a security vulnerability. And who expects that printing a file name could be a vulnerability? In addition, you could have no knowledge of certain files' character encoding, which could result in what they call a emoji bake, which is an older Japanese word than we know. But now with the emoji craze, you can understand that that's just taking a bunch of emojis and having a bake off or whatever. It's crazy. But yes, it seems like disallowing /r/n and leading dashes in file names would make a big difference. I've kind of seen this coming as an option for ZFS, just a property you could set on a file system, and it would just reject evil file names.
It would just be like sane file names equals sure or something, right? Right? Yeah, because this. You convinced me. I mean, after you get through the second example, I'm like, wow, this is really complicated, needlessly so.
Yep.
Okay. Well, very cool. Appreciate it, Alan, and hopefully they get some traction with that. Of course, it's a big deal to make a change like
it's
this.
How in particular, how do you deal with files that already exist, or programs that expect to be able to name their files that way? It's like,
that's right.
If you reject the file being written, that causes one set of problems. But if you just silently replace the bad characters with an underscore or something, then what happens? The program writes a file and then tries to close it and open it, and it can't find it?
That's...
Or, what happens if you're trying to create a new file with the bad characters, we replace them, but that file name already exists. Should it connect to the already existing file, or is it obvious that you meant a different file? You could easily blow your foot off with this.
Yeah, this is the kind of thing it would be very dangerous to do on an existing data set, right? You'd have to do it from scratch when you start. But anyway, we wish them luck with their efforts here. Maybe something will come out of this, and in the future we'll be creating file systems with some different flags so we can use the same defaults.
They also have a link of a bunch of the different CVEs or CWEs for all of these, including the top 25 most dangerous programming errors and how they cause problems.
Okay, time for the news roundup, and we're going to be starting here with a little bit of OpenBSD news as it relates to ARM64. So tell us, what new platforms are they offering?
Yes, so they're basically adding their port for ARM64, specifically targeting the Pine 64 and the Raspberry Pi 3.
Oh, okay. Those are a good couple ones to start off with. That's fantastic. So let's see here. It says they're bundling various shared platforms sharing the 64-bit ARM architecture due to the fact there's so many systems on chips around. OpenBSD's ARM64 differentiates between these SoCs and may have different levels of support between them.
Yeah,
of course.
So it's a little harder than say with AMD 64. We can just say we support all AMD 64s because each SoC is a little bit different and has different hardware and so on. So they've broken down what they have here for driver support as well. So they support the SMSC LAN 95XX driver for the Raspberry Pi 3 and the USB hub that's built into the Pi 3 and the Pine 64. It mentions that neither of those currently have a real-time clock because they don't have the battery backup for it. So you might want to use the -S option when you invoke OpenNTPdate to allow it to skew the clock a large amount, because it'll be wrong when you boot it. And I imagine more drivers will show up here as they work on it, and additional platforms as people port to the different SoCs. As of last night when I wrote this, the link to the FTP to actually download the snapshots is still 404, but I imagine by the time this episode comes out next week, those images will be up and you can try it out on your Pi 3 or Pi 64.
Yeah, that'll sound neat. I imagine we'll see a spate of new, using my Raspberry Pi 3 as a PF router on OpenBSD. Like, we'll start seeing those articles shortly after.
The Pi 64 has better Ethernet, doesn't it? I don't know.
Okay, maybe
but they don't list the driver for that one yet, so maybe they don't have the Ethernet working on that, but they do on the Raspberry Pi 3.
Okay. So. Cool. Okay, well, next up, it seems like every few episodes we end up discussing ciphers in one way or another with their oh-so-amusing naming, and today is no exception. So we have a great write-up on kind of the design and implementation of the Cha-Cha-20 cipher written by Loop Villaint. And first of all, is this story for you? So maybe the summary will help you make that call. So I'll just read the summary here. A quick summary. Cha-Cha-20 is an ARX-based hash function keyed running in counter mode. It embodies the idea that one can use a hash function to encrypt data. So if your eyes didn't glaze over as I read that, you're probably cleared to proceed with the rest of this article. So we're good.
To explain it simply, the way the cipher works is you take your plain text message, and then you do an XOR, which basically just means in binary, it's like if one of the bits is set, it's you flip it, and if they're both set, anyway.
Yep. Hey, we're getting to that. That's what they're going to be telling us about in this article. So, of course, they mentioned Cha-Cha-20 is built around stream ciphers, and I'll read a couple quotes here. They said, while Cha-Cha-20 is mainly used for encryption, its core is a pseudo-random number generator. The ciphertext is obtained by XORing the plain text with a pseudo-random stream. And then they give an example of ciphertext, and then your plain text is XORed to some Cha-Cha stream with a key and a nonce. And he said, provided that you never use the same nonce with the same key twice, you can treat the stream as a one-time pad. This makes it very simple. Unlike block ciphers, you don't have to worry about padding, and decryption is pretty much the same operation as encryption. And then they show the example here, how you get the plain text back by taking the ciphertext and XORing it with the Cha-Cha stream with the key and nonce again.
So that's,
now we just have to get that stream.
The interesting thing about a XOR is if you do it a second time, you get back the original message. So that's the very basic of encryption, right? You take a message, you XOR it with some secret code, and it changes the characters. And then if you XOR it with that secret code again, you get back the original. And so the very original version of this is the one-time pad where you just basically make a list of random characters and both people have a copy and it works. The problem is it requires you to somehow securely get this one-time pad to both sides. So then we usually have some other system to come up with that random key. And so
like the shared library or the shared pad.
Yeah, so instead of having a one-time pad like that, the idea with Cha-Cha is that you have a key and a nonce, which is just a random starting number, and you use that to basically use the hash to generate this stream of random characters that will be, you can always generate the same stream as long as you give it the same key and the same nonce, but if people don't know the key and the nonce, they can't generate that same stream and they can't decrypt your text.
Correct. So from here, the article pretty much goes into depth on how the cipher scrambles 512-bit blocks using the quarter round method. So fourth of the block or four 32-bit numbers being what the quarter round is in this case. I don't know if you can show on the screen here, Alan, but he's got some ASCII art used to visualize how this is done in the quarter round phase. It'd be kind of hard to describe without showing it. And then the complete block is the 4 quarters are then run in parallel across the entire 512-bit block. So they do that to, looks like to speed it up a little bit so you can run things in parallel. From here, the article goes a bit more in depth, looking at the complete Cha-Cha block as the importance of a seemingly unnecessary 32-bit byte constant is explained. And hint, it actually is really, really important. So if crypto is something you find fascinating, you'll want to make sure you give this one a full read through. There's a lot of depth here on how this works internally. A little bit over my head, I got to be honest. I'm not much of a crypto guy. So, but I know there's a lot of our listeners who are, so you may find this fascinating, and hopefully that gives folks ideas and helps make the future of cryptography even better.
Yeah.
Okay, so time for our next sponsor this week, which is going to be IX Systems, and the website for that, ixsystems.com/BSD Now, where you'll want to go there, and there's just a little form you fill out, name, email address, phone number, that kind of stuff. Give them some contact info so one of their sales engineers can get in touch with you and figure out what sort of next platform you need to have built. Are we talking storage? Are we talking compute? Are we talking little FreeNAS minis? Are we talking a whole IX rack of gear, basically a wheel in your own cloud, essentially, where you have the storage and compute and everything in one rack.
I think after the cloud is right at the point now where people are realizing that on-prem has many advantages.
It does.
You don't have a 40 gigabit per second internet connection, but if you have an IX rack, right, you can have 40 gigabit between your stuff and your cloud.
That's right.
That's hard to argue with.
Run your cloud. That is very hard to argue with. Yeah, we've moved a lot more stuff here to this office because we have better internet, but it is nice to be direct into the QA boxes, for example.
Much faster.
Anyway, yeah, you definitely want to talk to the folks over at IX and tell them you heard about it here on BSD Now, because they like hearing from our listeners, and that kind of just lets the sales engineer know that, we're speaking to somebody who's a little smarter than the typical Joe. Like they're going to know a little bit more about Unix and Linux. Then that'll help them ask the right questions, right? Like, okay, what kind of database are you doing? What kind of files are you storing? What's your CPU load like? They want to get into the nitty gritty with you, because that'll help them make a good determination of, no, you don't want this processor. Intel has this other processor that'll actually perform better in your particular use case. Or, maybe these particular disks aren't the ones you want to buy. No. You want to spend more money on your ARC, or more money on having some spinning disks with some SSD caches, or maybe NVMe is the solution.
Yeah, especially now they have these new 3D XPoint NVMe's coming, but they only, as far as I know, only go up to 32 gigs. So they can make a great ZIL, but they're going to be expensive. So it's like, do you need the 16 gig or the 32 gig? And then, how many of these are you going to put in? And, are you going to have the right number of PCI Express slots?
No, that's right. So they're going to know all those things and ask you. This isn't just a pre-built system off the shelf that they're just trying to offload to you, and hopefully it fits your needs or not. They're going to definitely take care of you, listen to what your concerns are and your needs, and make sure that whatever solution they come up with meets those expectations. Okay, well, time for our next story here. So we got a CyberChef coming to a FreeBSD port stream near you. What is CyberChef?
Yeah, so that's a good question. So CyberChef is a simple, intuitive web app for carrying out all manner of cyber operations within a web browser. So this is actually from the GCHQ, which is basically the British version of the NSA. These operations include creating hex dumps, simple encoding like XOR or base64, more complex encryption like AES or Blowfish and DES and so on, data compression and decompression, calculating hashes and checksums, doing IPv6 stuff or X509 parsing, and much more. The tool is designed to enable both technical and non-technical analysts to manipulate data in complex ways without having to have deal with complex tools or algorithms. It was conceived, designed, and built and incrementally improved by the various analysts in their 10% innovation time over the last several years. Every effort has been made to structure the code in a readable and extendable format. However, it should be noted that the analysts are not professional developers, and the code has not been peer-reviewed for compliance with formal specifications. But, it has various handy functions, like he mentions, base64 and so on. But there are also a lot of more interesting ones, like this one here that does a network enumeration. So parse IP range out of the networking chunk.
Sure.
You type in an IP range like 172.21.0.32/27. So you enter a CIDR mask. It breaks that down, gets the actual subnet mask for you, which, I have trouble remember those sometimes. Prints out the range of addresses, and then actually prints all the usable addresses for you.
That's
lots of stuff like that. But, like that Cha-Cha thing, if you wanted to actually see how XOR works, you can actually do that here, right? So if we go under encryption and encoding and just do a XOR, kill this other one, set up the XOR. We'll just use a hex key of 1 or something.
Sure.
And then I just type, this is BSD Now. We see that everything has been XORed with the key 1. Now, if I change it to 1, 2, you can see that every character does this. Now, if I take the ciphered text and put that as the input, when it gets XORed with that same key again, you get the output. But what's really cool is if you use this other one they have, the Xorg brute force, you can actually have it try to guess the key. Right? So I put in my encrypted data, and if it tries all these different keys, we see that it doesn't. We get all these different versions of gibberish, and then all of a sudden, it found that key outputs the original plaintext. And so you can actually give it a crib, or basically a known plaintext string. So if you know that the BSD is in there, then it finds that if you XOR it with the key 12, you get this is BSD Now. Turns out also if you XOR it with the key 32, you get this is BSD Now with inverted uppercaseness, just because the key happened to work out that way with ASCII. But, if you have some data that was just done with a XOR, if you're analyzing some malware and you know that they just used a simple XOR with a short key, this would allow you to brute force that and figure which key it is without having to sit there and try them all manually or whatever.
Sure.
It also has a browser user agent parser. So you can, if you see something in your browser log and you paste it in, it's like, oh, that's Chrome. Because if you've ever seen the browser user agent string for Chrome, it says like Mozilla and WebKit and Safari and a bunch of other things, and nowhere in the string anywhere does it actually say Chrome. But their database that's built in here allows you to actually figure out that one's Chrome versus that one's Firefox versus that one's Safari.
That's neat.
And it's all open source and on GitHub, and they accept pull requests. It's all written in JavaScript, and it seems to be fairly easy to work with. They also have a cool tool here called the to calculate the entropy, or how random something is. So if we look at this random string that was XORed from the real text, but if we go under here and get the entropy tool, and we put our input, we see that the Shannon entropy for that is actually only 4.5, which is right in the range for English text. So even though it looks very random, this tool shows us that it is, in fact, not very random. It's slightly more random than the original text, but not. Whereas if we actually have real random stuff, we'll get a higher value.
That's neat, Alan.
Anyway, cool little tool, and apparently Dan is going to put it into the ports tree.
Yeah, I'll have to look forward to maybe by the time this episode airs, he's already got it done. I'm not sure how far his progress is with that. Okay, so next up we have building Electron and VS Code in FreeBSD 11. So I guess Visual Studio Code. So who's doing this? Another GitHub project, it looks like.
This is just some instructions up on GitHub on what you're going to need to do it, and the patch to do it. Although the patch is a bit messy, it's just basically cloning the Linux system libraries lines with a FreeBSD system library line and making the small alterations required. It looks like they've been working on this for a while, and they have a couple of different diffs and a changelog for it. But for those that didn't know, VS Code, or Visual Studio Code, is a source code editor developed by Microsoft for Windows, Linux, and Mac. It includes support for debugging, embedded Git control, syntax highlighting, intelligent code completion, snippets, and code refactoring. It's also customizable, so users can change the editor's theme, add their own keyboard shortcuts, and set their preferences. It is free and open source, although the official download is under a proprietary license. Visual Studio Code is based on Electron, which is a framework which is used to deploy Node.js applications for desktops running in the Blink layout engine. Although it uses the Electron framework, this software is not a fork of Atom, which is GitHub's similar editor.
Sure.
And it's
actually from Visual Studio's online editor.
But it'll be interesting to see this actually maybe eventually show up on FreeBSD as an officially supported upstream thing.
Running Microsoft code on FreeBSD now. What does the world come to?
What's more interesting is I wonder how well VS Code could actually deal with the FreeBSD code base. Every one of these kind of smart code editing software that I've ever looked at, you throw the entire FreeBSD source tree on it and it falls over very quickly.
It just blows up. I don't understand.
There's so much code.
Well, it says Git control. Does it have Subversion?
I don't think so.
Okay, so maybe you could use it with your Git clone of FreeBSD.
In particular, I think it's just this size, like the amount of lines of code in the FreeBSD repo.
Yeah.
Although,
We'll have to give it a shot and see. Like, somebody's going to try it. I'd be interested to see in what unique way it blows up. Okay, so it's time to do our Beastie Bits this week, but really quick before we do, Tarsnap. Of course, the website for that, tarsnap.com/BSD Now, where you want to go there right now and get signed up, download the client, and start doing your backups. You can put a few bucks in there. And first of all, because of its amazing dedupe engine, you'll be surprised how long that few dollars lasts. I mean, you're paying, what is it, pico dollars per byte month or something? I always get that. I always mispronounce it. I got it right. Woo. Okay. But no. I mean, it's just ridiculous, right? How little it costs. I think I put my original $20 in years ago, and last I checked, I'm like 17 or something. So it's crazy. Anyway, but yeah, if you're doing highly duplicatable data, Tarsnap's going to dedupe it for you. And the best part about Tarsnap is it's all deduped and encrypted on your remote end.
On
so
your machine
before a single bit
goes.
Yeah. Before anything goes up to the cloud. So it saves you bandwidth. It also means you can trust it. That means the key that you have in your little hands or on your desktop or whatever, that's the only key that's going to decrypt your data. So everything on the remote end is just fully encrypted and scrambled, which means anybody on the cloud provider doesn't have access to it. Nefarious third parties who maybe have gained access to the cloud provider don't have access to your data, which is what you want. You don't want anyone having access to it except you and yourself only. And of course, the nice thing is he even makes it convenient. The key can be printed out on one nice sheet of paper, laminate it, throw in a fireproof safety deposit box, and you are good to go. But
you don't have to just take my word for it either. If you go over to their testimonials page, they have a testimonial from Stripe, which makes me feel better because that's the credit card processor I use for my business. But also Robert Morris, famous originally for the Morris worm back in the early days, but is a famed security researcher. And so knowing that when he says Tarsnap is the most clean to design and convenient of any Unix backup schemes I've tried, that really gives you an idea that it's quite good. And then there's lots of other testimonials on here from people that, it's just serious business.
No, don't even believe them. Go audit the code yourself. If you're that paranoid, you have the source code. So last week in the comment section, we mentioned a user told us about how you can run this natively on Windows 10 now. Well, semi-natively. I guess you're running the Linux version through their new compat layer. But anyway, refer back to that if you'd like to run it on Windows without Cygwin, which is pretty cool as well. So anyway, tarsnap.com/BSD Now again. Don't forget it. Okay, so Beastie Bits. So let's get right into these. So Roy Marples of OpenRC fame has a new thing called soft label keys, which he's putting in a NetBSD. So tell us what exactly this does, Alan. I read it and I was like, that's kind of cool, but I've never seen that done.
So soft label keys are something that's specified by POSIX. It's supposed to be part of curses, but almost no curses implements it, and because of that, most apps don't use it. But it says soft labels rip off a line from the bottom of the screen and allow up to 8 keys to be displayed there. You can define labels for them, colors, etc. So it's kind of, I don't know, like Nano, where you can put the keyboard shortcuts and stuff down there.
Sure.
But it's a standard way of doing this, and if a lot of programs used it, it would actually be quite useful. Right? It says because the soft label keys also works with the term info database, it works in the terminal natively, and that supports labels. This means a line doesn't have to be ripped off from the screen, so no real estate is actually lost. Sadly, no terminal actually seems to support these markings, so if one is ever made, it should work fine.
Sure. That's pretty cool.
But so if you think of running your terminal in X or whatever, it could just be one line longer and not actually cost you any space that way. It says not many Curses apps actually use the SLK function, probably for this very reason, but some do, and it is a standard, so he's coded it up for NetBSD, so it will support it natively. Sadly,
cool.
This has uncovered a bug in the NetBSD curses library where cursor movement in a one-line window at the bottom of the screen appears to push the window up. He says this is very visible when SLK and will have to be fixed for any app that's actually using it. But the SLK implementation itself is sound, as resizing the terminal forces a redraw and it looks fine.
Okay, very nice.
Yes.
Okay, well, next up we have some OpenBSD news. It looks like they've disabled WPA1's TKIP encryption by default. So that's no longer a thing you can do with WPA1 on OpenBSD. So I can see they're continuing with their trend of getting rid of the old cruft
Yes,
and
so this
only
is
using the new. That's good.
Was the follow-on to WEP, I guess. Although, interestingly, did they remove WEP support? Because in Japan, that's pretty much everything.
I wonder if they have some flag you have to turn it back on.
Yes, because I remember manually. For a while on FreeBSD head, WEP was actually broken because it was not on the list of offloads that the wireless card supported, so it would ignore it even though there was software support for it. And I remember Sean Bruno and I sitting there in the hacker lounge in Tokyo one day, trying to figure out where the problem was, and it was actually a bug in WPA supplicant.
Go figure.
Yep.
Okay. Next up, we have cool but obscure Unix tools, with Christoph writes this. Christoph Kovacs. Got nice little pictures of a variety of different Unix tools out there. Some you probably heard of, some you haven't. So things like dstat and SAR, of course, HTOP, ATOP, glances. Let's see what else we have. TTY-REC, IPBT for recording and playing back terminal sessions. Let's see
obvious
here,
stuff
of course,
like
Vim
rsync and MTR, and screen and mux, but also detach and BYOBU.
I don't know what that one is. I've never used that.
SoCat is interesting. It's like cat, but for sockets. It's a little bit different than netcat, but it's interesting.
That's cool.
Multi-tail, if you want to tail multiple log files at once, you can do that with tail, but then it kind of gets all mixed up. This one actually slices your terminal up and allows you to watch the last couple of lines of a bunch of log files at once, which can be quite useful.
Nice. And of course, things like IFTOP.
IFTOP is a favorite of mine.
That's a good one. Yep. I use that pretty frequently as well.
And obviously XArgs, but a version of that called Parallel to actually try to do more at once as well.
Task Warrior, to-do management in the terminal. Can't say I've ever used that one. Ledger.
And there's some calendaring programs. There's LFTP, which can do FTP over SSL, RTorrent, and so on. A TTY version of Twitter, or TTY TTER.
RSS tail, which is a command line RSS reader. I did not know that exists. Yep. Very cool. And then, Twitter clients too.
And you have Cowsay and Steam Locomotive. Those are both funny. I don't know if people have seen SL, but it's common for people to mistype LS as SL, and when you do, a little train drives across your screen to remind you did it wrong.
Nice. Okay, well, yeah, definitely a good list of them here. Take a peek at those. Maybe some of them you'll know, some you won't, just like us. Oh, TIG, T-I-G, which is get backwards. A console UI for Git. Okay, I did not know that was a thing either. Very cool. Okay, next up we have KDE frameworks and Plasma for FreeBSD, and we have a little blog post about that here. It looks like they're just mentioning that they're still working on it. Gleb's watching over some things. Dima's been working on it. Raphael's working on it, but they're working on getting the official ports for KDE Framework 5. They said all except the Wayland port, which required a Wayland port to build against it. But hey, that just landed, so maybe that's about ready to go now. And there's some issues with the FreeBSD Bluetooth stack, which I'm sure is much different from Linux's. And I'm just looking here. So, there's work being done in FreeBSD's Fabricator too. Okay. So if you want to play with it, it looks like there's a Plasma 5 branch in the Area 51 repo, which is where all the KDE pre-release stuff development happens. And then also in FreeBSD Fabricator, there's some also. So anyway, it looks like there is some active development going on there, but they said don't hold your breath on it just yet. Yeah, there's still work to do.
But hopefully the other stuff we covered at the top of the show will make this easier.
Yeah, I would hope so. If Wayland was one of the things they're waiting on, well, that is now fresh. So, cool. Moving on here, the initiative to migrate OpenBSD's mirrors to HTTPS. So it looks like there's some traffic on that on the mailing list here. But they're talking about asking people to run mirrors to try and turn on HTTPS so they can do more clever stuff with the install tools. That definitely sounds neat. And it looks like this is a post by Theo here. And let's see.
Yeah, I wonder how they solve some of the problems of in the installer, how do they know which SSL certificates to trust? Since I imagine they don't ship the NSS root CA thing either, right?
I don't know. I don't know how they do that. Maybe somebody who knows will have to write in and let us know. But then we have a little link here, a picture of something in the FreeBSD wiki when you realize somebody in FreeBSD is a big Star Wars fan. And we have a picture here. I guess somebody's username is Jar Jar, which, again, if you're going to do something Star Wars, could we do something from one of the good ones? Like the crappy Star Wars? Anyway.
So this one's just... if your login on your local machine is not the same as your FreeBSD login, then there's just a line to put in your SSH config so that when you connect to svn.freebsd.org, it automatically sends the right username.
That's right. So definitely good stuff. Okay, and with that, we're actually going to wrap up the show here. So since we're pre-recording it this week, no questions and answers, but keep sending stuff in, and we will get it on the next live episode, of course.
The reason there's not is because you didn't write in enough, you lazy...
Well, we caught up, so I think I maybe got ahead of myself, Alex. I kept telling people we had a large backlog to work through. Well, we have worked through the backlog now from the holidays, so please send stuff in, and we will definitely get it on a future episode, and you won't have to wait very long because we're all caught up now. So, of course, send those into feedback@bsdnow.tv, which is the only address we monitor, so send everything there. Otherwise, there's a good chance we won't see it, and then it won't get mentioned on the show, and then you'll get upset like I spent all that time and effort to write this long, 3-page article, and they didn't see it. So send it into feedback@bsdnow.tv.
Yes. And
of course,
even if it's just to tell us about a blog post you did, we're always looking for more stuff. Especially this week, we had to do a double episode. It was like, we need more stuff.
Yeah. You got to scramble for a little more content and stuff. So that's good. Keep that stuff coming in. We will definitely appreciate it, and we'll work it into a future episode. And, of course, we'll look forward to talking to you again here soon.